Hey, Mr. Dean here, another video. This time we're talking about the transformations of the sine and cosine waves, their graphs. Particularly in this video, we're talking about the amplitude and the vertical shift. So just switching things in the y direction. Let's take a step back, look at the unit circle, see what's happening here. The values for, say, sine, how they're changing. So sine on the unit circle is the y value, and at 0 degrees, the y value is 0. And you remember, as it goes around, it starts to get larger and larger. It gets to a maximum of 1. All right, that's very important. So the sine of 90 degrees gets a maximum value, and that value is only 1. And as it gets back down the other side of the circle, it goes back down to 0. And as you get down to the third quadrant and into the fourth quadrant, circles around a minimum of -1, but then starts to rise again in quadrant 4, and the values of y, the values of sine, go back up. So here's an old-fashioned table. You can see the values of sine as the angle goes from 0 to 45 degrees. Sine is increasing. For cosine, it's the other way around. Cosine starts with a maximum, so the cosine of 0 is 1, and then they trickle down and down. And tangent's a little different. Tangent doesn't maximize at 1. It keeps on going past this, but it does get into negative values eventually. So keep this in mind as we move on to thinking about the graphs of sine and cosine. So I've sort of stuck kind of awkwardly here a unit circle onto this graph just to show you that for sine at 0 degrees on the unit circle, we can graph that by putting the angles out along the x-axis, and they're there in radians. The y-axis here goes from -1 to +1, so the range of sine is -1 to 1. And as you go around your unit circle, you can actually plot these values. So there it is at half, and we go around. These correspond. So eventually you get to the very top of your circle, and there's 1, and there's the height. As you go around the circle even further, if I connect these sort of in a way to show you, we're graphing the y's until we get to 180 degrees, or pi, and the sine of pi is back down to 0. And it just keeps going around the circle. This one would be graphed there, and we take the y coordinate, and we can graph it there. We get to the minimum, -1, and there's our minimum. All right, so it just goes around in a circle eventually. As you get all the way back up to 2 pi, you've gone all the way around. There aren't any new values. So the period of sine, and for cosine, is 2 pi, all the way around the circle. And you can see that the values here, move this out of the way, you get some values in the negative direction as well, using that idea that 2 pi is equal to the period. So 1 period is really equal to any spot on the graph that repeats itself in the exact same way. So that's 2 pi, but really, take the two maximums there, that's 2 pi, maybe even these two maximums, and that's a period as well, 2 pi. Same thing goes for cosine, except everything now is talking about the x value. So x maxes out at 0 degrees. So the cosine starts, we really say the cosine kind of starts at the top and goes down. And that's an entire period of 2 pi. So we kind of use that word starts. Sometimes gets confusing. What we mean is that when it starts, we're really talking about 0 degrees, but of course behind this is all the values for your negative values too. So when we say starts, we really mean along the y-axis, and I'll be saying kind of that phrase a couple more times later on. Critical points of your sine wave then, when you start a sine wave, it starts right at 0, which is really the middle of your wave from up and down perspective, and maxes out at the very top at 1. I don't really have the y-axis labeled here, but I'll get that done. And comes back to 0 at pi, all the way down. Sine is at its minimum at 3 pi over 2, and back up to 0, all right, for a full period. We'll call this the maximum right there. We call the middle, sometimes it's the intercept. We'll see later on it doesn't always intercept the x-axis when you do transformations. And the minimum, of course, is the lowest point. Same goes for cosine. The only change is that we've sort of shifted the maximum to be at zero radians or 0 degrees. So it maxes out, starts at the max, and then goes down from there. So its period is all the way until it gets back up at the maximum at 2 pi. All right. Now we're ready for transformations of the sine and cosine functions. So the basic form of all transformations is this a times sine of b, and then parentheses x minus c, and then with a plus d tagged on the end. So there's 4 different types of transformations we'll look at, A, B, C, and D. Today, we're going to look at A and D because they transform your graph in the vertical direction. So let's look at specifically right now on this slide, we'll look at A, changes in amplitude. All right, the A can be thought of as abbreviation for amplitude, and the amplitude is always positive. The amplitude is the absolute value of that number. Amplitude is never thought of as a negative number. It's always positive. It'll expand vertically, in other words, make it taller up and down when that number is greater than 1. But if you have a number that is a fraction, then it will contract and actually shrink vertically. It will be less tall, it will be shorter. And when the value of A is negative, you have the whole graph sort of flipped over, which is kind of a layman's terms for, we'll do this. And let's say here in this particular case, it's not really the best graph, but A is 2. If you had A is negative 2 instead, then the whole thing is, that red graph is sort of symmetric about the x-axis there. Take a look at more specifically how it changes in amplitude. We have right now, here's the equation for the graph. We have an amplitude of 4, and of course, changes in that direction just make it look taller. Now you notice all the peaks to the graph, the peaks will stay right where they are in terms of the x-axis, but they'll get higher and higher depending on what you set A is. Now as I go down in A, and we get towards negative numbers, so there's 2, there's an amplitude of 1. No surprise when I press 0, what the graph will look like. An amplitude of 0 is just a straight horizontal line. And negative. Now it might be hard to see the change there, but if you look specifically, this is a sine wave, but it's starting off downward. All right. Sine normally for positive numbers, let me go back to positive numbers, starts off positive, starts off in the up direction. So that's the difference you need to be aware of when you have a negative amplitude. Things are going to start looking down. The next transformation we'll look at is a vertical translation. That's the D number. That's the number down the end there. All right. It isn't always at the end of your function. It's just added on. So sometimes it may be at the beginning of your function. It's a number that is added on or subtracted on, and it's kind of away from sort of the busyness of what's going along the trig function itself. So it's kind of separate. And the D number simply moves the entire graph up or down, if it's negative, D units. So the graph will be symmetric about the line y equals D. And when we sketch the graph, we always want to dash that symmetry line. And I say it's called the new middle of your graph. And we'll look at an example in just a moment. So D is sort of the new middle. And we use that idea with amplitude in today's lesson, some examples. All right, so example 1, y equals 3 sine x minus 2. Well, first of all, let me go up to this green graph. What does sine look like again? Sine starts in the middle, all right, and heads up. Now, where will it be? At 2 pi, it'll be back there. And at pi, at 180 degrees, sine is also 0. So I kind of use those guidelines. I want to go all the way up to 1, and I want to go all the way down to -1 and back up for one period there. All right, so that's just sine x. In my first example here, a is equal to 3, and my d number is -2. So what I do is I work with the d number first. That's my new middle. And I'm going to look at my graph here on the y-axis, and as best I can do, I'm going to put a dashed line there. That's a terrible dashed line, but use your imagination. And then our amplitude is 3. So from our new middle here, from this line, we're going to go up 3 units. So I'm going to go 1, 2, 3, up to 1 here. And I'm going to dash that also. That's sort of the roof. That's the maximum values that this graph will have. I'll go back to my middle at -2, and I'll go down 3 spots, and I will dash that, and that represents the minimum values that the graph can take. All right, so my sine wave now, let's go back to my up here where the regular sine is. It starts in the middle, but my new middle is at -2, so I really want to start there. I have a period of 2 pi, so somewhere over here, I'm going to be back at -2. And for sine, the sine of pi is also the middle amount. And so I have those 3 dots to kind of start me off. In between 0 and pi, I don't have it yet here, but that's really pi over 2. The value that I should graph here should be a maximum. So I'm going to touch upon there. And then in between pi and 2 pi, which really is, barely fit at 3 pi over 2, I should have a minimum value. So I should be way down here. All right, you can kind of see now I got kind of a pattern. I can even extend that over to there, extend that out to my negatives, even off the screen, why not? And my graph will be a nice, smooth, not jagged. All these values are changing ever so slightly. No sudden moves with sine. And so that's a pretty good graph done by hand. I'm fine with that one. I would have liked that green line to be a little neater, but I'm going to move on. Next example, cosine. All right, getting back to cosine, thinking about what cosine basically looks like. I start at the maximum, and 2 pi later, I have another maximum. In between at pi, I'm at a minimum. And so my graph, halfway, go through there too. So halfway between pi and 2 pi, I should be going right through there. All right. So my critical points are my maximums, my intersects of the x value, and my minimums. All right. So just a review of cosine so that I can tackle this one. -8. It looks like a itself is -8. The amplitude is equal to +8. So it's just a, I don't know, a convention that amplitude is always positive. And d is 2. And d can be negative or positive. We saw negative before. We'll see +2 here. So I'm going to draw my new middle. Don't forget that. And I'm going to try to do a good dashed line there at 2. And then I'm going to go up 8 and down 8 from that middle, because the amplitude is 8. Notice that the amplitude is not 16, right? There'll be a difference of 16 between my minimum and my maximums. But amplitude is only the difference between the middle and the maximum, or the middle and the minimum, all right? So that distance there, that's the amplitude. Just as a reminder, that's 8, which matches up. That's the same distance between the middle and the max, and the minimum is 8, all right? So either way, I think we're ready to graph here, just keeping in mind that it's a cosine wave that starts at the maximum up here. At 2 pi later, it's going to be at the maximum. In between 0 and 2 pi, it is at the very minimum. So it is at the bottom of your wave at pi. Now remember that your middle, your new middle, is here at 2 and not along the x-axis any longer. So when I come down, I want to hit right in between 0 and pi. There's pi, there's 0. I want to cut through right in between there, hit that minimum, and then do the same thing on the way back. I want to kind of be in between pi and 2 pi right as I intersect and come back up to my maximum. Now sometimes the homeworks or the graphs will say to continue on into the negatives, so we can do that. I want to be in between there. All right, not the neatest of graphs ever, but this will do. All right, and hopefully that gives you an introduction to all our vertical changes, the A number and the D number for trig graphs. Our next video, we'll talk all about changes in the X direction.